In this lesson, I'll show you how to transform equations from rectangular to polar form. This is part 2. The question reads, convert the following rectangular equations to polar equations that express r in terms of theta. We'll start with the easier of the two, question A. Here we have a rectangular equation in terms of x and y. 3x minus y is equal to 6. To go from polar to rectangular coordinates, we use the following two formulas. The first one being x is equal to r cos theta, and y is equal to r sine theta. The easy part of these questions is to substitute where you see x and y with what they're equal to. So let's go ahead and do that. We have 3 times r cos theta minus what y is, which is r sine theta is equal to 6. Like I mentioned, this is the easy part. The hard part comes when it's time to solve for r. Notice that both of these terms have an r in common, so we'll factor that out. This gives us 3 cosine theta minus sine theta is equal to 6. And now we divide both sides by this factor, where we have r is equal to 6 over 3 cosine theta minus sine theta. That's the answer for A. Let's move on to B. This time our rectangular equation is slightly more complicated. We have x to the power of 2 plus y plus 2 in brackets raised to the power of 2 is equal to 1. To do this, we'll be using these two formulas once more. And I'll start by replacing this x with r cosine theta. We have r cosine theta raised to the power of 2. This r becomes r squared, and cosine theta becomes cosine squared theta. Furthermore, I'll replace this y with r sine theta. We have r sine theta plus 1, and that's being raised to the power of 2. So picture this right here plus the following. The next thing that I want to do is expand this expression. And we can expand it by using the FOIL method. We have r sine theta plus 1, r sine theta plus 1. This term times this term gives us r squared sine squared theta. This term times 1 is equal to itself, r sine theta plus r sine theta plus 1. And don't forget this part, which we can just add to the end. All of this is equal to 1. The reason why this has been given a medium level difficulty is because you need to use some identities to figure this one out. I'll group this term and this term together, where I have r squared sine squared theta plus r squared cosine squared theta. In addition, these two can be combined. 2r sine theta plus 1 is equal to 1. This 1 and this 1 will cancel out. Just imagine taking this 1 over, it becomes 1 minus 1. So the right side is equal to 0. The reason why I combine these two is because sine squared theta and cosine squared theta, once you factor out r squared from both, is an identity. Let me show you. Sine squared theta plus cosine squared theta is equal to 1. So technically, this whole term becomes r squared plus 2r sine theta is equal to 0. Now we have two terms and they both share an r in common. R plus 2 sine theta is equal to 0. Now I can set r is equal to 0 and this part, this factor, also equal to 0. We'll have to decide which of these two is correct, and we will in a moment. Now, I want to solve for r here. I'll take this over. I end up with r is equal to negative 2 sine theta. Between these two equations, this is the only one that works, because this tells us that nothing exists. We have a radius of 0. Whereas this one gives us an opportunity to go back to what we started with. You can convert this back into rectangular form, whereas this one you could not. And there you have it. 2 more examples on how to convert equations from rectangular to polar form.